let's get into the graphing aspect of simple rational functions. First of all, we're going to start by identifying the transformations. Again, I know it's repetitive, but we do know how to do this. So identify the transformations given by a, b, h, and k. And then it says to apply the transformations to the asymptotes, to the reference points, and then state the domain and range using inequality, set notation, and interval notation. We're just going to go ahead and stick to set notation. As you guys noticed in the previous video, I ended up using interval notation instead of set notation. So we're going to go ahead and leave that. But I do want us to focus on set notation just because this is a little bit easier to work with when working with asymptotes in rational functions. Now, before we get into the graphing part, let me give you a quick little shortcut to the transformation of our points. Okay, so our reference points are 1, 1, and -1, -1. These are the reference points regardless of what our function looks like, because remember, these come from the parent function. So in order to apply the transformation to these reference points, we're going to take them and we're going to apply the transformations of a, h, and k. So how do we do that? Well, we know that h affects our graph horizontally, right? It's a horizontal translation. So we're going to take our x value and add h to it. I wrote down 1, but let me change that to an x because this will apply to both of our transformation or both of our reference points. So we're going to take x plus h, and then we're going to take the y value, multiply it by a, because remember, a is a vertical stretch or compression, and then we're going to add k to it because that is a vertical translation, so it'll move it up or down. This is one of those formulas that you definitely want to know because this is how we're going to be graphing our our reference points. Okay, so let's go back here and let's go ahead and start with a. A says g of x equals 3 times 1 over x minus 1 plus 2. Start by identifying your transformations, which means a, h, and k. So a is 3, which means we have a vertical stretch. Then we have h. H is 1, so that means it moved right. And then we have k, which is 2, so that means it moved up 2. Okay, now asymptotes. Remember, x equals h, y equals k. So we have a vertical asymptote at x equals 1, and we have a horizontal asymptote at y equals 2. Okay, so let's go ahead and graph that. Asymptotes are always the easiest to begin with. We're going to go ahead and graph those. X equals 1. And remember, this is a dashed line because technically it's not there. It's just our boundary line. And y equals 2. So now the question is, where are the reference points? Because we moved our point of intersection here, remember on the parent function, here is where it lies, and we moved it up to over 1, okay? Let's go ahead and see what the transformation is going to look like. So we're going to take our reference points. Our reference point was 1, 1 and -1, 1. And remember, we're going to apply these transformations here. X plus h, y times a plus k. So that means we have 1 plus 1, x plus h, and then y, which was 1, times a, which is 3, plus k, which is 2. We simplify, and our first reference point is located at 2, 5, right? 1 times 3 is 3, plus 2 is 5. So here's one reference point. Do the second reference point. We had -1 plus 1, comma, -1 times 3 plus 2. So you can see the only thing that changed here was our reference points. 1, 1, -1, -1. Everything else stayed the same. Simplify, we're at 0 and -1. These are the 2 points we are interested in, okay? Going back to our graph over here, let's go ahead and plot those points. So 2, 5 is right here, and 0, -1 is down here. Now, because we're only using 1 point, this is where you have to go in and think, what is my graph going to look like? Consider these reference points your turning points. So I'm going to start here at the actual point, and I'm going to drag my graph towards the asymptote, right, and just write it along it. Same thing in the other direction, that's my turning point. So from there, I'm going to turn it into the asymptote and write along the asymptote. Then do the second point. Remember, it is a turning point, so curve it towards the asymptote, curve it towards the asymptote, and we have our graph. Now, of course, this is not going to be perfect because we did not find any extra points. We are simply basing it off of the asymptotes and the reference points. If you want to use your graphing calculator to find additional points, you are more than welcome to do so. Remember, the more points you have, the more accurate your graph is. All in all, that is the gist of graphing rational functions. Asymptotes, reference points. Okay, now domain in set notation. Let's stick to set notation. So my domain, curly bracket, defining for x, we know that x cannot be 1. Look at how much simpler it is to write our domain in set notation as opposed to interval notation, right? Makes it a little bit easier. For the range, we define for y that y cannot be equal to 2. And there you go. That's all there is to graphing rational functions. Let's try one more. Looking at b, we have g of x equals 1 over x plus 3 minus 1. Start by identifying transformations. There is no value there for a. A is 1, which means that it is unchanged. H is -3, which tells us that our graph moved left. And k is -1, which tells us that our graph moved down. Now, once again, x equals h, y equals k, tells me that we have a vertical asymptote at x equal to -3, and we have a horizontal asymptote at y equals -1. Graph those two asymptotes. So x equals -3, and y equals -1. Remember, these are just our guides. There are boundary lines. Now, identify your reference points. Where are the reference points located? So, once again, we're going to start with 1, 1. And remember, it's x plus h. So, x plus -3. And y times a, which in this case, a is just 1. It's not going to change it. Plus k, which is -1. Simplify. 1 plus -3 is -2. 1 times 1 plus -1 is 0. So we have a point at -2, 0. That's one reference point. Second reference point, -1 plus -3. And -1 times 1 plus -1. Simplify. -1 plus -3 is -4. -1 times 1 plus -1 gives us -2. So second reference point is at -4, -2. Plot those points. -2, 0, and -4, -2. And you can see how close we are to the asymptotes. That's okay. Remember, use those points as your turning points to guide your graph. Start at the center, curve it towards the asymptote in both directions. So there's one part of our graph. Same thing on the other reference point. Start at the center, curve it towards the asymptotes in both directions, arrows at the end, and we have our graph. All right, now hit the pause button. Go ahead and try C and D. All right, those should have been pretty simple because they were already written in what we would call standard form of a rational function. However, if it's not written in this form, then we have to rewrite it in order to be able to graph it. So if you look at the next example, A, it's just a rational function, 3x minus 4 over x minus 1, which means that we have to rewrite it in order to be able to graph it. And the way we do this is by division. And we do use long division to do so. And you guys will see it's really not that hard. It's actually pretty simple. So we're going to take our divisor, put it on the outside, and we're going to take our dividend and put it on the inside, right? So numerator and denominator. Now, remember when we divide the inside by the first term of the divisor, okay? So 3x minus 4 divided by x is 3. And then we take that value and we multiply it by the entire expression. So we're going to multiply 3 times x minus 1, which gives us 3x minus 3. Then we flip our signs because we subtract the whole thing. So 3x becomes negative, negative 3 becomes positive, and we perform the operation. 3x minus 3x is 0, cancels out. Negative 4 plus 3 gives us negative 1. Okay, now x does not go into negative 1, so here is how the rewriting process occurs. Okay, we know that our quotient is written as the as our whole number, right? So we would have 3 plus the remainder over the divisor. You just rewrote your fraction in standard form of a rational expression, a times 1 over x minus h plus k. Now, here is what you have to keep in mind, okay? Your numerator, when you do rewrite it, has to be positive 1, right? This is positive 1. If it is not a positive 1, you're going to bring it down as the a value. So in this case, we have negative 1. We need to bring that negative down as our a value. Your quotient actually becomes the k value. So we're just going to go ahead and flip it here so you can see what I mean. Okay, so we have negative 1 over x minus 1 plus 3. 3 is positive. Okay, remember this sign does not belong to the 3. We know that 3 is positive based on our division, so we add it over at the end. And then we're going to take that negative sign and bring it down as a negative 1 in front of our fraction to make it our a value. So here is what our function says. We have negative 1, and you can write the 1 or you can just bring down the negative sign, times 1 over x minus 1 plus 3, and you have just created your g of x function. This is what we're going to graph. This is what we need in order to graph, right? Look at your transformations. A is negative 1, so we know we have a reflection over the x-axis. H is positive 1, so it's going to move right. K is positive 3, so it's going to move up. Okay, remember, x and h indicate our asymptotes. So we do have a vertical asymptote at x equals 1 and a horizontal asymptote at y equals 3. Graph that. Then we can go ahead and take our reference points and apply the transformations. Once again, x plus h times, or comma, y times a plus k. So we're going to take our reference point here. Let's start with 1, 1. And we have 1 plus 1, comma, 1 times a, which is -1, plus k, which is just 3. Simplify, and we have a point at 2 and 2. 2, 2. That's one reference point. Our second reference point, and I'm just going to go into the same expression here and change that to -1. So -1 plus 1 is 0. And -1 times -1 is 1, plus 3 is 4, making our second reference point 0, 4. Plot those. 2, 2, and 0, 4. Use them as turning points here towards our asymptotes. And we have our function. Okay. Now, again, we are asked to state the domain and range using inequality, set notation, and interval notation. Let's just focus on the set notation part. Domain, defined for x, x cannot equal 1. And range, defined for y, y cannot equal 3. And there you go. That is how we rewrite our function in order to graph. All right, example B does use a B value, so we're going to go ahead and skip this. I don't want to confuse you. We're not going to focus on B. Let's move on to C. All right, C says 3x plus 8 over x plus 2. Remember, set up your long division. X plus 2 into 3x plus 8. Divide one more time. 3x divided by x is 3. Multiply. Remember, we're multiplying by the entire expression. So 3 times x plus 2 gives us 3x plus 6. Change our signs. They both become negative. Perform the operation. 3x minus 3x cancels out. 8 minus 6 gives us 2, which means we have 3 plus a remainder of 2 over x plus 2. Flip it. We're writing our remainder first, quotient second. And now you can see here what's going to happen with our a value. Remember, we need a 1 to be in our numerator, so we're going to take that 2 and bring it down as our a value. So this changes into 2 times 1 over x plus 2 plus 3. And if you're thinking, why can we do that if it's not our quotient? Well, remember, when we multiply a whole number times a fraction, it only gets multiplied to the numerator. So 2 times 1 is still going to give me 2 up in the numerator. We just rewrote it in a different manner. Here's our equation. Okay, based off of our equation, we know that we're going to have a vertical stretch by 2. We're going to move left 2, and we're going to move up 3. So what does this tell me? It tells me that we have a vertical asymptote at x equals -2, so it's moving left. We have a horizontal asymptote at y equals 3, so it's moving up. Reference points. Actually, let's graph the asymptotes first. -2 for x, +3 for y. All right, now reference points. So we have 1 plus h, which is -2, and 1 times a plus k. Simplify. 1 plus -2 is -1. 2 plus 3 is 5. There's one reference point. Second reference point, change it to -1 instead of +1. -1 plus -2 gives us -3. -1 times 2 plus 3 gives us +1. And there's our second reference point. Graph those 2 points, -1, +5. And -3, 1. Create your turning points there. Turn towards the asymptotes. And we have our graph. All right, hit the pause button. Go ahead and try D. Now for this next part, your graph should have the asymptotes and the coordinate points already plotted for you. However, I missed that on your notes. I apologize. So go ahead and hit pause really quick. Copy this graph down so that we can talk about how to write the equation given a graph. Now that you've copied this down, let's go ahead and talk about how do we get it from a graph into our equation as a simple rational function. Okay, so we know we want to write our equation as a times 1 over x minus h plus k. The way we're going to start this off is by identifying h and k. And remember, h and k comes from our asymptotes. So if we can identify this point here, which is 3, 4, then we're already a step ahead and we know our h and k. We're also going to need one extra point in order to be able to identify our a value. So pick a point, whether you want to use 4, 6, or 2, 2, it does not matter. I'm going to go ahead and use 4, 6 and plug it in for x and g of x. Remember x, y, this is going to take the place of every variable in the equation except for a. So when I plug all of this information in, I know that x is 4, g of x we said was 6, h is 3, and k is 4. So let's go ahead and plug that in. And we have 6 equal to a times 1 over 4 minus 3 plus 4. Simplify, and we have 6 equal to a times 1 plus 4. A times 1 is just a. Remember, do not add it to 4. You multiply it to a. And then we solve for a, which means a is equal to 2. Plug everything back in except for x and g of x, because remember, that can be any point on the function. And we are left with a simple rational function, g of x equals 2 times 1 over x minus 3 plus 4. How easy was that? There is the equation for the given function. Now, I told you guys we're going to skip B, so go ahead and cross B off. Here is C. Once again, I apologize, you do have to copy it down, but go ahead and hit pause, copy this down, and then write the function for the given graph, and come back and check your work in a minute.